I'm very excited to introduce and welcome this next panel to come up, our first panel of the day, actually. And good friend Ed Niedermeyer, a fellow journalist at one point, is the Director of Communications for PAVE, and that's the Partners of Automated Vehicle Education. Ed lives up in Portland. He's got a great background, again, in journalism. I love listening to him on the podcast, Autonocast, and of course, wrote a book recently called Tesla, and used the word ludicrous. I should have a plaid cover now, Ed. You've got a great panel here. I'm just going to talk by names. Nicole, Alison, and Bruce, I'm going to let you introduce your panel, Ed, and thanks so much for all of you for being here today.
Thanks so much, Charlie. Yeah, hello and welcome to our panel, Staying in the Loop, How to Safely Advance Driver Assistance. The previous speakers were discussing sort of the rise of driver assistance, and that's what we'll be zeroing in on today, with a real focus on sort of the increasingly automated aspects of driver assistance. And human in the loop automation generally. So I'm joined by Nikhil Naikal of Velodyne. He's the VP for software development. Welcome.
Hi, good morning, Ed. Good morning, everyone. Good to be with you.
From Audi, we have Alison Pascale. Alison, good to see you.
Nice to see you, Ed.
And from MIT AgeLab, Bruce Mehler. Bruce, welcome.
Good morning, all. Good to be here.
So Nikhil, I want to start with you. Let's sort of set the stage here, because and talk about sort of how technology is really leading to sort of progress in the level of automation that we're seeing in driver assistance, and sort of summarize the progress for us and some of the things that are kind of driving it.
Sure. I'll kick it off, talking, this is the World Safety Summit, and so I'm going to talk about advanced driver assistance systems and how they've been contributing to improving safety. So if you think about driving itself, I think recently WHO had a report that about 1 million people around the world are killed due to traffic fatalities, and about 50 million injured or disabled as a result of this. And according to NHTSA, 94% of these accidents in the US are caused because of human error in driving. And what you're starting to see with the advent of advanced driver assistance systems is a positive trend in the reduction of these kinds of highway accidents. Again, over the past 3 years, I think NHTSA and the National Safety Council did a study that year over year, there has been a reduction over the past 3 years in highway accidents and increased safety, reducing and addressing human errors when it comes to driving. So that's one of the most beneficial aspects of driver assistance. Of course, there's convenience to the driver itself, being able to help you back out of your driveway with a backup monitor, being able to help you switch lanes using a blind spot monitor, or stay within your lane using a lane keep system. These are all convenience features. But in addition to that convenience, safety is the other aspect that makes driving more pleasurable and better for you and other people around you, like vulnerable road users, pedestrians, other vehicles, bicyclists, etc. So I actually, when I think of this problem of improving, you asked what are the developments that are pushing this forward and moving this forward. Amongst other things, one of the key enablers over here is sensor fusion. Redundancy is the name of the game, right? When you have different types of sensing modalities, you have cameras, you have radars, you have Lidar today, and all of these sensing modalities together, especially given how complementary they are, how orthogonal they are in the way in which they measure and sense the environment, enables for these systems to be more and more robust, right? So it's increasing redundancy, and increasing robustness through redundant systems. Someone who I respect a lot told me this once recently, about a year ago, that you think of it this way, that if you have a camera that fails at detecting a pedestrian 1 in 1,000 times, a radar fails 1 in 1,000 times, and a Lidar fails 1 in 1,000 times, the combined effect is a failure of 1 in a billion. Now, that kind of redundancy is an enabler for safety, right? So you don't no longer need to rely only on the human to be the redundant eyes on the road, but you can increase this through sensor fusion of more and more modalities to make these systems more safe and bring them to market in a safe and broad manner.
Yeah. Thank you. That was a great overview. Alison, so as Nikhil described, right, we're seeing sort of more more kinds of sensor modalities in even in production vehicles. We're starting to see Lidar go into production vehicles, and this is enabling these higher levels of automation in these driver assistance systems. But at the end of the day, these systems, right, there's two parts of it. There's the technology in the car, but then the human is part of that system as well. Is there some risk around, the possibility that we might forget a little bit about that human aspect of these systems?
Well, I'd first like to say that adding technology to vehicles over the years is what automakers have done with great success to make driving very much safer than it used to be, starting with the simple technology like seat belts and airbags and electronic stability control. These are things that helped protect the driver and allow them to survive a crash. But now we're on to sort of the next possibilities of crash avoidance technologies where we can avoid the crash altogether. But with this is you get extra sensing, as Nikhil was describing, an extra set of eyes or 2 or 3 extra sets of eyes to help the driver be a better driver. But we have to understand that so far these are driver assistance systems. They're not self-driving systems. So a key component is ensuring that the driver is part of this equation and making sure of that as the technologies get better and better. And as drivers get more comfortable and maybe become inattentive, there's really a strong necessity to have a good driver management system, good driver monitoring to ensure that the driver doesn't disengage, to call the driver back in with reminders and escalating alerts to remind them that they may not be paying attention. So together, this system can make the human driver a better driver. It's encouraging that this month Euro NCAP just came out with a new rating of these assisted driving systems, and actually the traditional automakers scored quite well. Audi scored very well, and one thing they look at is a balance, as you were saying, Ed, between whether the system drives really well for you and how well the system keeps the driver in the loop, how well the system keeps the driver engaged. And it's a combination of making sure there's collaboration in allowing them to drive and have steering input, as well as reminders that bring the driver back when they do become inattentive.
Yeah, it was really interesting. You mentioned both driver monitoring and driver management. I want to dig into there's sort of an implied progress there. But first, I want to ask Bruce. You at MIT, you're involved in some really fascinating research into sort of seeing how these systems are really being used in the real world. I was hoping, could you maybe just describe briefly some of the research that you're doing, particularly around the naturalistic driving study using these systems, and then sort of are you seeing some of the things that Alison voiced some concern about in how people are using this in the real world, the inattention, things like that, the need for better driver management?
Certainly, those are all really important concepts. But in speaking about inattention, the first point I'd like to make is that inattention is not just an issue in the car. You can walk down the sidewalk and, how many individuals are you going to notice have their eyes buried in their smartphone instead of looking at where they're going? So in fact, directing attention to other things other than the outside world is in many ways the new normal. And we see this not only in the case of automation, but once again, in the car, we see an increase in secondary task engagement under manual driving. So it's a major issue per se. So in the project that I'm associated with, the Advanced Vehicle Technology Consortium, we're going and we're observing how people are actually engaging or not engaging with systems in the real world. And we have a fleet of Tesla vehicles where actual owners have allowed us to instrument their vehicles and watch them for over a period of time. That's a particularly interesting arm. We've watched some people for up to 4 years in their natural behavior in the environment. We also have a fleet of vehicles that we own, that we've instrumented, that we issue to people for a month at a time. And once again, watch how they interact or don't interact with the systems in the vehicle. And, you know, there's a number of things that we observe. You know, we see people on the cell phone, we see people eating, you see people singing, you see people talking to passengers, all the kinds of secondary tasks that have been observed for a number of years. But we definitely do see an increase both under manual driving and under automation. And this is extending as far as we watch people going and reading the newspaper in the car, having work documents that they're turning the pages on as they lean them against the steering wheel. You know, it's one thing to think about people holding the cell phone in their hand. We were watching people take full iPads and lean them up against the steering wheel and work away like this while they're theoretically supposed to be paying attention to the road. So automation is not a cause of distraction, but it definitely increases the pull. So we have this pull that's taking place for people to do things other than the driving task. And in some ways, if they're going to do that, under automation is the logical place to do it. So it's an increased pull and a challenge. It's also a particular concern because, of course, when you're engaged in that secondary task, you're not doing that backup role at the level the model calls for because you're not seeing everything that is going on. And so as automation increases, inattention to the road is going to increasingly be a challenge. And somewhat ironically, it becomes more and more of a challenge the better the automation gets. Because as the automation becomes more and more reliable, it becomes harder and harder to maintain that vigilance. You know, the automation's doing so well, why can't I pick up my smartphone now? Is going to be the natural pull. I'd also like to note that inattention is more than just eyes off road time. One of the important things that's coming out of some of the work that we've been doing is noticing that it, once again, it's not just the off-road time. That, of course, is a problem. But it's also whether or not people are bringing their eyes back up to the road and keeping on the road long enough to reestablish some situational awareness of what's going on. So in fact, what we're really interested about from the monitoring side is not only are we looking for when people are looking off the road, but when those eyes come back up again, do they stay up long enough to actually build a model of what's happening on the world? So how effective a backup can the driver be, once again, if they're inattentive? So there's also this major concern around de-skilling. As we drive less and less, then there's that challenge of when the driver suddenly gets called on to actually back up, take over control. That's in fact the most challenging time, and the level of skill in the driver is probably not where it was originally. So both inattention and helping the driver come back into the loop in a way in which they can respond in an effective way are major challenges for us.
Yeah, and it sounds like this is sort of where we get from, you know, beyond just sort of driver monitoring into maybe some driver management, as Alison was suggesting. Alison, could you just sort of break that concept down? What does that mean to Audi? You know, going beyond driver monitoring to driver management.
Yes, that is true. We do like to call this driver management because it's a way of keeping the driver the goal here is to support the driver, not replace the driver, and that is what drivers want. 71% of drivers want technology to support them, not replace human driving. People still like to drive, but they want all the benefits that come with these extra sensors and reducing some of the cognitive load of the tedious parts of driving, where it just tires you out to stop and go, or keep your tense hands tightly on the wheel. So it's a benefit to the driver, but as Bruce was saying, there's a tendency, if you get reliant on this technology, your mind might wander. So it's finding that sweet spot of keeping the driver engaged enough and having the types of reminders that the driver is willing to respond to and does respond to come back into the loop. And they've found that using a carrot versus a stick has been very effective. Drivers really like these systems, and if they hear an audible or a visual reminder to come back, they will, because if that escalates and they don't come back into the loop, the system, they'll lose access to the system, and they don't want to. So the findings are that people want to use these systems, and it's a matter of just doing really good HMI research and design so that the systems are intuitive, they're easy to use, they're easy to understand. It's super important that people know what these systems can do and what they are doing, and with a glance. So we do a lot of testing to know what consumers like, what they don't like. Consumers didn't like lane departure warning beeps. They much preferred the haptic seat rumble, and it's probably because if they had passengers, they would be embarrassed that their passengers would hear maybe that the beeping might indicate they're a bad driver. So you're trying to find the systems that really work best to drive the behavior you're looking for. And then it's really important. I mean, I see that PAVE sponsored this session, and driver education is super important, especially as technology gets more advanced in vehicles. It's really important that consumers understand what is in their car and how to use it properly, and also to know system limitations so that they don't over-rely on the technology. I would also point to IIHS is recommending that it's important to have shared control of the vehicle in these level 2 vehicles. It's a way of keeping the driver engaged, allowing the driver to have steering input, to drive around a pothole maybe, and not have the system disengaged. So there's lots of good ways and good best practices to really have good driver management.
Yeah. The inattention part is something that I think gets talked about a lot. I think maybe that piece that you mentioned, Alison, about how it's important that these systems be designed in ways that people actually enjoy using them, so that they actually are used, so that you actually get the benefits from them. Nikhil, are there things that can be done on the sort of system sensors, that can actually sort of make them better to use, not just more capable, but actually better to use, and so that the consumers are more likely to use them and get the benefits from them?
Yeah, both Bruce and Alison made really good points over there, which is having the human as the fallback to be able to take over control when you have limited reaction time is very challenging. And so when it comes to having people ready to use this or engaged in case there's about to be an accident, they have to somehow have an evasive maneuver. That's really, really challenging. I mean, however advanced systems get, however advanced the handoff gets, at the end of the day, you're relying on people's cognitive abilities to be able to do that sort of takeover. The other way around is definitely a more plausible way. You could have the system, in fact, that's already happening, where an inattentive driver who doesn't pay attention to an animal that has jumped in front of the vehicle, the system applies a brake for them, takes over control, and says, you know what, I'm going to slam the brakes, because if you don't, the car's going to hit the animal, right? So that kind of thing is already, as Alison was saying previously, is already starting to make driving a lot safer. But when it comes to that sort of handoff where, or that spectrum where it's so reliable that people are now starting to trust the system more and more. We're now starting to enter that phase. Bruce was talking about people using their cell phones, eating food, using their tablets, etc., fixing electronics when they're driving. What's enabling this? It's not just the sensors, it's not just the hardware, it's also the software. Right, you really need software that gets better and better, understands the driving task better over time, and gets better over time. Things like lane departure, right? If you have a system that's constantly beeping at you, like Alison was saying, you're not really going to use it. You're going to say, I don't want this thing. I'm going to turn this off. It's not useful. Having good haptic feedback in the form of the vibrating seats, as Alison was saying, is definitely a step in that direction. But there are times where the system has to get smarter so that it is avoiding false positives, things like when the driver is driving properly and is paying attention, is centered within the lane. If the lane departure warning, whether it's in the form of a beep or if it's in the form of a vibration, if that happens, then the driver's trust in the system is going to go down, right? So those false positives need to go down to essentially zero. You want to have very high precision in these systems so that it doesn't ghost brake, hallucinating an animal crossing the street, or give a ghost seat vibration or a haptic feedback thinking that you have deviated from the lane. So that's the sort of the lower bar, that you want to make sure that the system on the one hand is very certain about the action that it recommends or it takes. On the other end of the spectrum, you don't want it to miss things as well. So you don't want missed detections. You don't want false negatives. You don't want it to, because it's not sure that thing in front of it is an obstacle or not. You don't want it, striking a vulnerable road user, right? So it's that trade-off between trying to have very low false positives, very low false negatives, that starts building the driver's trust. But then there's that second question of how do you do the handoff, which is a challenging one, handoff especially from machine to the human. And I think more research is needed over there.
Yeah. Bruce, again, I want to sort of try and help people understand in the research that you're doing in these naturalistic driving studies, are you seeing some techniques around driver monitoring or management being more effective in the real world than others? I know there are various tests, but in that real world sense, do certain techniques, approaches, philosophies, what have you, have better results than others?
The observations in the data is starting to trend in that direction. I would like to start off though in making one comment is it really is important to recognize the wide range of individual differences. Some people work with these systems in an incredibly responsible manner. So for example, like I talked about the Tesla fleet that we're looking at, where we're monitoring some people for up to 4 years. Some of these individuals are working really nicely with the system. They use them to reduce some of the demand of the driving on long travel, on long trips, etc. Do most of the steering, control the vehicle speed and spacing, but are paying attention and doing the monitoring that they should. At the same time, we see other individuals who are clearly abusing the system. Whether or not it's just simple overconfidence or whatever, it's hard to say. But I think everybody has seen pictures on YouTube of people sleeping in Teslas. It's very clear there's demonstrations of different ways of defeating the simple hands-on wheel torque detection. We see people balancing, Coke cans, etc., on the steering wheel, and clearly defeating that detection of whether or not they are theoretically engaged. So while the system itself, in terms of its basic driving, is phenomenal, the monitoring system leaves much to be desired. We've seen other kinds of systems, like in the Volvo, it's more a collaborative steering approach. There seems to be a little bit better engagement, less people trying to defeat the system there in the samples we've observed. Some individuals have indicated they're very comfortable with the kind of collaborative design. Other people feel less comfortable. They feel like, well, you know, are you steering or am I steering? You know, it should be one or the other. And in that question, you know, it's a big question about whether or not having hands on the wheel is actually necessary. You know, the Super Cruise approach in the Cadillac CT6, we're seeing some very positive indications there. You know, they have the driver-facing camera, which is basically focused on whether or not the individual is keeping their eyes on the road, as opposed to requiring them to steer per se. And that's an interesting challenge, but what we're seeing is that people are tending to bring their eyes back to the road fairly quickly. They quickly learn if I look off too long, the system is going to not be available to them. So it's not clear whether or not that's ultimately going to be the solution, but it's looking very positive. And I and a number of my colleagues feel that really camera-based monitoring is going to be a really key part of successful systems going forward.
Yeah, so we are running a little bit close to being out of time here, but Alison, I wanted to go to you since you mentioned a topic near and dear to my heart, which is education. And obviously all of us at PAVE are big believers in that. But sort of in the context of a system like this, where the human is really a part of a driver assistance system, it's a partnership. Sort of, you know, why is education so important to that, and sort of what can be done in terms of education to really ensure the highest levels of safety with these systems?
I mean, we're at a really important point right now where you see the technology that's in vehicles today, and people's trust in technology is going to be established now. What they think of lower levels of automation is going to impact what they think of higher levels of automation that are coming. So it's really important that we get this right. And a big piece of that is making sure both that the systems work well, but also that the driver and consumers really understand what these systems are and what their responsibility is. So for the companies and developers making these systems, we are really thinking hard about how to be sure we communicate well, how we train both our dealers and the customer on the technology and how they should use it, what the system limitations are. So that's really important. I would say for traditional automakers, you know, we're very aware of product liability as well. So we don't want to overstate what systems can do, and that's very important. And I would say that Euro NCAP made this clear. It scores on the accuracy of your marketing material. You'll get a reduction if you're overstating the capability of your system. So I think that's, you know, becoming understood that it's really important to speak clearly, honestly, and truthfully about what these systems are, and find, you know, the best ways to educate the drivers on how to use them, because they are an integral part of making it work. It's both the system and the human on level 2.
Yeah, absolutely. Well, that pretty much takes us to time. I'd like to just thank all of our panelists, Bruce Mehler of MIT, Nikhil of Velodyne Lidar, Alison Pascale of Audi. Thank you all for taking the time to help us understand this fascinating unfolding situation. It'll be exciting to see what happens from here.
Hey, Ed, and thank you for leading the panel in the discussion. It's amazing how quickly we run out of time in a discussion like this. It could certainly go on, and therefore I recommend everyone, you know, get a chance to listen to Autonocast where you have more time to go into this deeper. It was interesting to hear a couple of comments. I know Bruce, I'm assuming, was just referring to you when he said singing in the car. And then Alison finishing off with, again, limitations, drivers understanding the limitations. Because again, that's right aligned, Ed, with what you were tweeting earlier today, just in terms of people assuming that because they have these capabilities that they're just going down the road, again, unfortunately not paying attention as much as they should. So certainly something that we should all be thinking about. But thanks to all of you. Really appreciate your insight.